Okay, Assalamualaikum and a good afternoon, everyone. So today again, probably this will be our last presentation session. So today again, we have three people presenting, so we need to keep our time. 25 minutes of presentation plus another 5 minutes of Q&A. So for the first presenter, we have Muhammad Safwan bin Zaini, who's delivering his progress report. The talk is on green synthesis of carbon quantum dots by green carbonization method and its colloidal stability. So please, the screen is yours.
All right. Thank you so much, Associate Professor Dr. Hishamuddin and my fellow friends. So today I'm going to present my progress seminar. The title is the Green Synthesis of Carbon Dots from Watermelon Peels and its Colloidal Stability. So my name is Muhammad Safwan bin Zaini and I'm under supervision of Dr. Maziana Ahmad Kamaruddin. So today's presentation started with the introduction and then problem statement, and it will end up with the references. So as a introduction, will it be great if we could control individual atoms, or just imagine if we could turn them off and on to store a bit of information, make them light up with different colors, or control them in all kind of other ways. So simply speaking, so quantum dots are example of nanotechnology, and also can be defined as a particle with physical dimension smaller than the atom radius, and it is zero-dimensional system where they confine the exciton in all three spatial dimensions. So if we compare with the other things in this world, so quantum dots are really small. It actually is 60 million smaller than tennis ball, normal tennis ball, and then it's actually 10,000 narrower than your head. So it's really, really small. And for carbon quantum dots, or sometimes they call it carbon dots or carbon nanoparticle, or sometimes CQDs. So CQDs are small carbon nanoparticle, which is less than 10 nanometer in size, with some form of surface perturbation. And it was discovered by Zhu et al. In 2004 during the purification of a single wall carbon nanotube. And it has a lot of many advantages or merits of the CQDs. So first of all, it has a low cost, which is and then it has a really small size, and it's less toxicity compared to other material. So another advantage is it has a good fluorescent nanoparticle, and it can tunable and stable photoluminescence, and it can produce from the natural sources to produce the carbon dots. And it actually is environmentally friendly. So as for problem statement, first is previously to produce a carbon quantum dot, it has a complex synthetic procedure and the expensive chemical precursor to produce CQD. So the solution we propose, or we use green carbonization method to produce carbon quantum dots from watermelon peels. And then sometimes if we disperse in the solution or solvent, the aggregation and coagulation of CQD often occur. So in order to curb this issue, we study the stability of CQD by varying the pH of the CQD solution. And then to study the effect of carbon concentration in order to study the original study of luminescence of CQD. For objective, first one is to synthesize CQD from watermelon peels by green carbonization method, and then to investigate the colloidal stability of CQD on a zeta potential and photoluminescence of CQD, and then to determine the effect of concentration on the optical, physical, and structural properties of CQD, and to reveal the potential of CQD on the PV application. So here is the summary of the project. We have 4 objectives here, as you can see here. And for objective 1, the first objective is to synthesize CQD from watermelon peel by green carbonization method. So we begin with we chop the watermelon peels. So the red one, of course, we eat the red one. And then for the peel of the watermelon, we chop it and smaller to increase the surface area. And then we dry it under the sun illumination for around 3 to 5 days in order to absorb all the moisture. And then we carbonize it for 2 hours around 240 degrees Celsius, and then grind it in order to form a powder. We sieve it around 45 micron, and then we dilute with the solvent. And after that, we sonicate it around 30 minutes with the 5-minute intervals, and then we'll filter by 2 type of filter, which is 0.45 micrometer filter and 0.22 micrometer filter. Then we centrifuge it around 10 minutes with a 2 minutes interval. The final product is the yellowish solution of the carbon content in different solvents. So here is the PL photoluminescence of the carbon quantum dot. As you can see here, there is a different intensity of the photoluminescence when we disperse in the 4 solvents. But unfortunately for PL peak energy, there is no change in the PL peak energy here when we normalize the PL spectra of carbon content dot in the 4 type of solvents: the methanol, ethanol, IP, and butanol. So the first next is we use it and disperse the CQD in the 7 type of solvent, which is a methanol, ethanol, isopropanol, butanol, and the 3 types of water, which is ultra pure water, deionized water, and distilled water with different pH condition. And then for second objective is to investigate the colloidal stability of CQD on a zeta potential and photoluminescent CQD. So in this research, the main characterization to study stability is by zeta potential. So zeta potential actually is the charge that develop an interface between the solid surface and its liquid medium. Simply put, the surface charge of nanoparticle in solution. So is the diagram is the particle and the outer layer of positive counter ion first attached to the negatively charged particle, forming a layer what we call a stern layer, which is the first layer. And then the second region here is called a diffuse layer, and together both layers are referred to the electrical or electrical double layer. And then the slip plane here, the outer layer here, is where the stern layer and diffuse layer meet, and here is the electrical potential is called a zeta potential. So basically, the higher the absolute value of zeta potential, the more stable the dispersion. As you can see here is the average zeta potential in millivolt. If you get a zeta potential around 0 or negative or 0 to negative 29, it means that your solution is not stable. And if you get to produce a zeta potential around 30 plus minus 30 and above, that means your solution is stable. And this is another explanation of the how to get a zeta potential measurement. So here is the zeta potential value or result of our sample. So if dispersed with carbon content in ultra pure water, it has a value of negative 46.3 millivolt. That means negative sign here represent the negatively charged surface charge of the particle, and the magnitude of value of the zeta potential is a 46.3. So according to this zeta potential measurement, if you get a positive or negative 30 millivolt and above, that means your solution is stable. Same goes to the CQD if dispersed in the methanol. However, if you see here is another rest of solvent, which is ethanol, isopropanol, butanol, distilled water, and DI water, there is a possibility to particle to coagulate or aggregation occur is higher compared to the methanol and ultra pure water. So, and I would like to point out as the application of zeta potential measurement and how they are important in drying problems. So what you're looking at is the left one is a configuration where there is a glass substrate and there is a droplet of sample, and then this droplet contains a particle. So the fluid here will evaporate because of, if you take like there's a dispersion of water, and you will see that with time all the fluid will evaporate, and in the end there will be the deposition of particle on the glass substrate. So what happened in this drying problem is that when the liquid evaporate from the free surface of the drop, there is what we call the capillary flow. The capillary flow, and this capillary flow drives the particle to the contact line. So with time, what happens is that this capillary flow drives the particles, and it helps in the deposition of particle on the contact line here. So this is a classic phenomenon called coffee ring effect. That is because of the similar pattern are found when the droplet of coffee dries. So with this in mind, if we deposit the dispersion containing particles, which is carbon on the glass substrate, it turns out that there are conditions where we get a classic coffee ring effect, and of course there are conditions where you get a more uniform deposition of particle throughout the deposit. So now we could understand why such different deposition pattern have formed, even though we have considered a dispersion of a similar type. So the result you can see here, this is the for the case where the pH is about 1.5, and this is for the case where the pH is 6.5. And it turns out that in the case of pH 1.5, the particles are highly charged and the substrate is weakly charged. So in such cases, because of the electrostatic attraction between highly charged particles and the substrate, so there is a deposition of a layer of particles on the substrate. So however, once the layer gets deposited, there is a repulsion between the particle on the fluid and the particle that are already deposited on the surface. So there are a lot of free particles here in this dispersion or in the drying drop, and then these free particles are carried to the edge because of the capillary flow I mentioned before, and leads to the deposition of particle at the edge, giving such pattern. So however, if you look at in the case of pH 6.5, the substrate is highly charged and the particles are weakly charged, and therefore there are many layers of particle deposited on substrate because of the fact that the substrate is highly charged. So it can attract more layer of particle even though there is a deposition of particle on the surface. So it is still possible to further deposition, and all the particles are attracted toward the substrate, highly charged substrate, leaving no particle in the bulk and leads to more uniform deposition. So in problem such as drying of droplets, the fact that pH 1.5 we get a coffee ring effect, and pH 6.5 we get a more uniform deposition. So it can be explained based on the DLVO interaction, which essentially is the total DLVO interaction, the summation of the van der Waals forces, or van der Waals force of attraction, and the electrostatic double layer attraction. But however, in this case, the LVO interaction have two components, which is one is a particle-particle interaction, and then the particle substrate interaction. So depending the overall the LVO interaction, which is the summation of the LVO interaction, arising because of the particle present of particle, as well as the particle and the substrate that is give us the deposition in such cases. So another characterization is if we want to study the isoelectric point. So IEP is the IEP is the pH value at which zeta potential value is 0, which is implying no electric charge on the surface of a particle. So this is very helpful in the following situation, which is to predict optimum condition for dissipation stability, and then to determining the predominant chemical species on the surface of complex particle. So if we get the isoelectric point 0, that means your stable is will probably to aggregate more compared to other value of pH. Here we disperse the CQD in ultra pure water and ethanol. For the acidic condition, we add the hydrochloric acid, and for the alkaline condition, we add the sodium hydroxide and ammonia solution in order to give the basic condition. Here is the result of our zeta potential or isoelectric point of CQD in ultra pure water. So according to the IEP, if you get a zeta potential around 0 to 30, that means your sample is not stable. And if you get more than 30, that means it has reached the maximum stability of the colloidal solution. So in here, in the acidic region, around pH 1.5 to 5, it has around -5 to -29 millivolt of zeta potential. That means it has a least condition or unstable condition. However, for the alkaline solution, it has reached a maximum stability when we reach the pH from 7 to 11, which is if we put the sodium hydroxide compared to ammonia solution. And then objective 3, to determine the effect of concentration on the optical, physical, and structural properties of CQD. So what we see, what we use here, we vary the concentration of the carbon content dot in ultra pure water from 0.2 to 1 gram per milliliter, singles to the methanol. But this is still an ongoing process. So we will characterize them by using UVVs, photoluminescence, TEM to study the particle size, as well as the dynamic light scattering in order to get the hydrodynamic diameter of particle and FTIR, but still in an ongoing process. And for UVVs, there are still two results only. In the carbon content in the eye water, the absorbance peak at 294.1 nanometer, and then for the ethanol is 258.9 nanometer, performed in the spectral region of 220 to 800 nanometer. So this is a preliminary study. For expected result in TEM, what we expect the size of the carbon quantum dots around 2 to 6 nanometer expected from the carbonization method. But in here is the ongoing result for DLS, TIR, purity experiment by high performance liquid chromatography, and NPL, and then we would like to continue for objective 3 and 4. So here is the Gantt chart of our research, my research. Now he's 2022 June, so we expect to finish all the characterization and synthesis by end of 2022, inshallah. So here's the references, and thank you so much.
Thank you, Safwan. So now open for Q&A from your peers first. Any questions? Okay, Lao Yinjan, go ahead.
There's this chat in this.
Okay. So let me read it. May I ask about the aim of the FTIR in your project?
So thank you, Lawyer Chen, for this question. The question is, may I ask about the aim of FTI in your project? The aim of FTIR in our project is to find the functional group of our sample, which is we disperse in the 7 solvent, which is 4 type of alcohol and 3 type of water. So if we disperse in the those type of solvent, we will see investigate the functional group of the our sample.
Yeah. So let's move on. Any other questions from your peers?
Yes, Prof.
Okay, Bashir.
Mr. Safwan, thank you for this very wonderful presentation. I really enjoyed the knowledge shared. I have just maybe an observation and maybe a question. First of all, in your title, as you said, you are going to synthesize the watermelon. Based on a little experience I have, the title should indicate how you will apply the synthesized material, as in you didn't indicate what are you going to do with the watermelon synthesis right from the title. It was when you go deep, then I began to see you are applying it for the photovoltaic application. So this is just an observation. And my question is, since you intend to, can you hear me?
Yes, Bashir.
Yeah, since you intend to apply the synthesized material to the photovoltaic application, do you propose the means of testing the efficiency of the material or of the synthesized material? Because I know later you will test its efficiency or photovoltaic application. So do you propose any method for that? Thank you.
Thank you, Bashir, for the question. For the application of our sample in the photovoltaic, is now we try to consider to apply in the dye sensitized solar cell, which is around from the sample of cadmium selenide, and we try to attach the carbon dots in this structure where we don't know whether we put it into the electron transport layer or hole transport layer, also or as a photosensitizer of the dye sensitized solar cell. So according to the result, we will try soon. We complete it until the objective 3.
Okay. I hope that answers the question. Any more questions from your peers?
Okay. Thank you, Safwan, for your wonderful presentation. I want to ask about the UVV slide. Can you move to the UVV slide? Yeah. Before this, the slide number 33. Yeah. Here. Can you explain what happened to the peak between 300 to 350? What the absorption of that?
So from the derivation, so it looks like there is two peaks here, within 300 to 350. So probably it's due. It comes from this C double bond O. Sorry. So Sorry, Farah.
You have some audio problems or?
Okay. You means that there's no absorption occur at between the 350 to 300, right? There's no absorption there.
Safwan? Safwan, are you there?
It's okay, doctor.
Okay, I'm not sure whether someone is having problems with the his connection, or are you still there, or should we, I suppose we could move to the next presenter. We still have time though. Safwan, are you okay?
Sorry, Prof. There's some internet problems in my area.
Okay.
Still,
Okay.
are you still listening me?
Pardon?
Are you still listening me?
Yeah. Okay. Let me. If there any other one final question from your peers, if they would like to ask on your presentation. Anyone? I guess not. So I think let's thank Safwan for the presentation, and then we'll try to move on to Ali Jabbar. So you may unshare your slide. So Ali Jabbar,
Yes,
are you
doctor.
here? Okay, good.
Yes, doctor.
So we will have him speak on, this is his final seminar, synthesis and characterization of erbium oxide, dope, zinc, borosilicate glass, and a layer of gold nanoparticles for optical biosensor applications. Please.
Assalamu alaikum, and have a nice day for Dr. Hushamuddin and all my classmates. My name is Ali Jabbar Abed. My mathematical number is GS57998. My supervisor, Prof. Kamirul Amin Maturi, and co-supervisor, Dr. Josephine and Dr. Mohad Hafiz bin Mohad Zaid. My title about synthesis and characterization of the erbium oxide, doping zinc borosilicate classes, and a layer of gold nanoparticle for optical biosensor application. This is my outline of study, starting from introduction and ending by conclusion. The biosensor is an analytical device which used to determine the presence of the concentration of the substance in biological analytical by converting the biological response into electrical signal. Used in many applications, such as in medical field, a biosensor is a device that consists of two main parts, which is bioreceptor and transducer. The transducer is the viscochemical detector compound that converts the recognition of the event into the measurement signal, as you can see in the figure. Many researchers try to improve the route of developing the optical-based sensor by utilizing the different optical techniques such as surface plasmon resonance and surface enhanced Raman spectroscopy by using the sensitivity and selectivity of the optical properties, because it can use in sorry, do you hear me? Because it can be provide an accurate and fast diagnosis of disease. Raman enhancement effect is attractive phenomenon for the fundamental study of both light matter and matter-matter interaction, and also for microanalytical application. Among the numerous Raman enhancement techniques used, surface enhanced Raman spectroscopy and surface plasmon resonance has been most intensively studied, but there is still remain many gaps regarding the enhancement mechanism. There are two mechanisms in the surface enhanced Raman spectroscopy and surface plasmon resonance, which is the electromagnetic mechanism The enhancement of the local electromagnetic field around the metallic structures, which is clearly explained by theoretical and experimental studies. Also, the chemical interaction between the absorption and the substrate, which is poorly understood because it is the effect of a smaller magnitude than the electromagnetic effect, and it is usually covered up by the electromagnetic effect. The surface plasmon resonance occur when the photon of incident light hitting the emitter surface, typically called surface, at the certain angle of incident, a portion of light energy coupling through the metal coating with the electron in the metal surface layer, which is moved due to the excitation. The electron movement are now called the plasmon, and they propagated parallel to the surface, to the metal surface. The surface-enhanced Raman spectroscopy is surface-sensitive technique used that enhancing Raman scattering by molecular adsorb on rough metal surface or by nanostructure such as the plasmonic magnetic. No matter which kind of the mechanism is operative, the substrate is obviously fundamental for the absorption of surface-enhanced Raman spectroscopy and surface plasmon resonance enhancement. The silicon-based substrate has little Twixley and responsible for the biological and biomedical application of provide study have primarily concentration on the use of zinc and boride. Using many researchers using zinc to add the stability, the class, and increasing the class forming ability, and other researchers using the boride. It can be product class that low phonon energy, high thermal stability, and high chemical durability, and easy to fabricate. Nowadays, many researchers using the Erbium to improve the optical properties of some glass by getting the high emission efficiency, high chemical durability, and thermal stability. This making it suitable for using on the optoelectronic application. On the other hand, intensive research has been carried out to using the metallic nanoparticles such as gold on the optical condenser as a starting material in the synthesis process. To improve the sensitivity of the sensor. In this study, we have two parts. The first part to synthesize the first layer, which is erbium doping zinc borosilicate glass, and study the structure, physical, and optical properties. Also to preparing the coating gold on the surface of the glass substrate to getting the second layer by spin coating method, and will study the elastic and optical properties of it. For the problem statement, the surface plasmon resonance and surface enhanced Raman spectroscopy technology are very convenient way to detection small molecular, thereby leading to diagnosis of disease. Nevertheless, the current state of art has multiplicated gap that needed to be addressed, normally in sensitivity and selectivity. The main issue with the Raman scattering absorption is the intensity of the scattering signal. Only 10⁻⁻12 incident photon will scattering, resulting in the Raman characterization being an particles tools without significant enhancement in the signal. So to solve this problem, the progress of doping in the class sensing platform will changing the optical properties by changing the reflective index. Consequently, that will increase the sensitivity as well as clearer surface enhanced Raman spectroscopy and surface plasmon resonance signal. The single use of traditional surface enhanced Raman spectroscopy and surface plasmon resonance substrate not only increasing the production cost, but also increasing the difficulty of the subsequent validation experimental. Therefore, using the previous research, using the boron nitride to getting the reusable traditional surface enhanced Raman spectroscopy and surface plasmon resonance, but this have many gaps because resulting is negligible charge transfer interaction with the molecular adsorped on the surface, hence provide a very low Raman enhancement factor. So we're using the gold because it gives a surface plasmoresic signal at a convenient component of reflective angle and wavelength. Moreover, gold is chemically inert to solution and soliditize, typical use in the biochemical content. In addition, gold will be able to protect noble metal against corrosion at high temperature, which hence provide an important route for the reusable surface enhanced Raman spectroscopy and surface plasma process. Third problem, there are also limited investigation being done on the effect of erbium doping transparent silicate-based glass substrate, especially on the structure, elastic, and optical properties of the glass system. The current study involved as investigate of the effect of the erbium on the physical structure and elastic and optical properties of zinc borosilicate classes substrate and affect the coating. Therefore, this research was done to achieve several objectives as mentioned below. First, to synthesize the zinc silicate classes at best material using conventional multi-quenching method with different concentration from zinc from 0.4 until 0.6 weight percentage. Second, to determine the base ratio of boron 0.1 until 0.3 weight percentage in order to fabricate the transparent zinc borosilicate classes. Third, to investigate the effect of erbium on the physical structure and the optical properties of the transparent substrate. The objective number 4, to study the effect of gold nanoparticle coating on the surface of the glass substrate by using spin coating method and study the physical, structural, and optical properties of glass substrate. The literature review, Zihra et al. 2012, studied the preparation, the formation of the photoluminescence properties by using multi-quenching method and finding with increasing the zinc silicate comparing with the boron oxide ratio, the PL emission band over the UV region decreasing in the intensity shifted slightly to the blue region. Schuval et al. 2014 studied the gold nanoparticle assist surface enhanced Raman spectroscopy and luminescence of the erbium doping zinc sodium tolerated glass, finding the glass sample with 0.4 mole percentage from gold display the highest luminescence intensity with the enhancing factor. Colberg et al. 2016 studied the forming of the crystallization of the zinc borosilicate class influence of zinc oxide comparing with boron oxide ratio. By using multi-quenching method, the density of finding the density of sample increasing with the increasing in the percentage of zinc oxide comparing to boron oxide. Pimendola et al. 2017 studied surface plasma resonance in gold nanoparticle as a review and finding the plasmon is highly responsible to many factors, either interested to the gold nanoparticle of the environment and they needed for the correcting standing electromagnetic approach with the quantum effect. Norrezela et al. 2018 studied the physical and optical study of the erbium doping the borosilicate classes by using conventional multi-quenching method, finding the backing density increase with the increasing the erbium oxide concentration up to 3 mole percentage. CT Asia et al. 2020 studied the optical properties of zinc silicate classes as a host for the green phosphors and finding the green and yellow and red emission for it. For the methodology, I prepared the first layer of a class with different concentration from zinc from 0.4 until 0.7 and different concentration from boron from 0.1 until 0.3 weight percentage. Then I doing the different concentration from erbium from 0.01 until 0.05 by weighing mixing for 30 minutes and melting at 1450 degrees Celsius for 2 hours and quenching in stainless steel mold preheating at 500 degrees Celsius at another furnace. when I did my first samples, I got in the crushed and broken the samples. So I discussed with my supervisor to do remelting at 1450 degrees Celsius for another 3 hours. Then quenching into the mold, preheating at 500 degrees Celsius at another furnace. Then I doing the cutting. The cutter machine is broken in my university, so I went to the USM in Penang to getting cutting, uh, uh, the cutting, and then doing the polishing. Further analysis, such as density and molar volume, FTIR, XRD, PL, and ultrasonic measurement, and UVVs and refractive index studied. Then I prepare the second layer. The second layer will coating the gold nanoparticle on the glass substrate by spin coating method at 1 minute and 7 seconds for 25 ampere to getting 50 nanometer thickness for the gold by using the spotter coater machine. Then I submit my sample to Raman spectroscopy, AFM, and SPR spectroscopy. I do the SPR spectroscopy. I did the SPR spectroscopy in UKM because there is no machine in my department. For the result and discussion, density is the very important measurement to know the change of molecular packing inside the samples. As you can see, for the density result for the zinc silicate, the increasing in the density may be related to the heavier the atomic mass of zinc comparing with the element, another element. And the density will increasing from 2.8 until 3.8 with increasing the concentration of the zinc. For the density result of the zinc borosilicate classes, can observe the density is decreasing with increasing decreasing after 0.2 weight percentage from boron. The decreasing the density may be related to the lighter the atomic mass of boron comparing with the element present in the zinc borosilicate such as zinc and silica. For the density of the density result of the zinc erbium doping zinc borosilicate classes, we can see the density will increase first until 0.4, then decreasing at 0.5. And the molar volume will increasing from 22 until 27 with increasing the concentration of the erbium from 0.01 until 0.05. The XRD result of the zinc silicate can all result of the glass samples registered at room temperature with lambda is 1.5 at 2 theta between 20 and 80. From the spectra can observe there is the most intense peak at 25.62 and 31.5 and 34.6 and so on, which corresponding to 101, 10, 110 and 410 respectively. Clearly can observe there is no sharp peak in the 0.6 weight percentage of silicon samples. This refers to the amorphous phase. As a result, it is the optimal zinc oxide ratio to obtain the transparent glass substrate. The result from XRD for the zinc borosilicate and the erbium doping zinc borosilicate, we can observe there is no strong sharp peak, but one broad hollow peak in the pattern of the glass samples. The broad diffuse is around a low angle at 30 degrees Celsius in entire glass samples, which reflective the glass or amorphous nature of the samples. Clearly can observe that a less intensity at zinc silicate, zinc borosilicate is 0.3 of boron, comparing with the samples, which means it is the best ratio for getting the transparent substrate. The FTIR result The FTIR result, the information of the functional group of a class can be studied using the infrared spectrum measurement. In the fact region of the spectrum observed from 500 until 1250 centimeter minus 1, the result of the FTIR confirm the presence of the SiO4 and ZnO4, which agree well with the XRD result. And the FTIR result for the zinc borosilicate classes, it can be clearly observed that the intensities for the band attributed to the symmetric stretching of SiO4 at about 908.7 centimeter minus 1 degrees, which decrease successfully and increase the peak of BO4 and BO3 at 1060 and 1258 centimeter with increasing the boron oxide. Generally, the overall spectrum of a crystal materials will have much sharper band than the spectrum of the amorphous material. So the result from FTIR are a good agreement with the result of XRD spectrum, which revealed amorphous phase for the entire class samples. For the FTIR result for the erbium doping zinc borosilicate classes, the inclusion of erbium oxide in the class sample cannot be detected by using the FTIR. This can be associated with the presence of the little amount of concentration of erbium oxide, which is 0.01 until 0.05 in the class sample. Despite having erbium oxide in the class samples, this element only breaking the bound of the boron oxide. Therefore, the BO3 can be detected in the FTIR spectrum. The UVV spectroscopy, the ultravisible spectroscopy is very important measurement and it provide information about the functional group or impurities of the sample, and it is useful to detect conjugation of the compound. Can use it in getting the energy band gap. As can you see in the figure 10 until figure 12, the show from the absorption curve, there is no big sharp absorption edge which detect the present glass samples. From the absorption curve, it can be observed that with increasing in the boron and erbium concentration, the absorption intensity increase and the intensive absorption, which can be seen in the region of 350 until 450 nanometer. The optical band gap, the analysis of the optical absorption spectra is useful to locate the width of the band gap in order to identify the substance from the spectrum emitting our absorption light in the metal. We can get in the experimental value by plotting the extinction coefficient with H mu. Then we can choosing the different concentration from N, which is half and 3/2 and 3 and 2, to getting the optical band gap at different value of N. Then we can comparing between the conventional curve with the value of N. As a result, there is the optimum experimental value of the optical band gap arise in the class system by direct allowed transition, because there is N equal to 1/2. The optical band gap value decreasing from 3.3 until 3.1 with increasing the erbium percentage of the as can be seen in the figure 18. We can, after comparing all the obtained optical band gap value in the tables, a good agreement, the optical in the differential curve with the value of N equal half can be observed. Hence, the obtained experimental value of the optical band gap decreasing in the class system by direct allowed transition. It is can observe that the value of the energy gap, band gap, decreasing with the increasing in the concentration of the erbium. An increasing number of the dangling, which related to the increasing number of the dangling bond in the structure of the sample, leaded to the fabricate a more localized state, which consequently led to reducing in the energy band gap was observed after irradiation due to the increasing the non-bridge oxygen and defect inside the samples. The PL result, the PL is technique used using in measuring the purity and the crystalline quality of the quantification of the amount of disorder present in the system. PL measurement usually depend on the local structure and electron configuration of the luminescence material. The main emission is 422 for the zinc silicate, which is the blue emission. While for the boron, there is the high emission at 688, which is the yellow emission. And for the zinc, erbium doping zinc borosilicate classes, we can use many emissions, such as the highest one is 422 nanometer, which is the blue emission. And the highest intensity was seen at 5% of erbium. The refractive index is the value of calculate from ratio of the speed of light in a vacuum to that in the second medium of the greater density. The refractive index, as seen in the figure 22 and figure 23, the refractive index in the glass substrate will increasing with increasing of doping concentration from erbium. The above increasing in the refractive index could be explained by the incorporating of relatively high atomic weight, 167, and the longer ionic radius, 232, at the rear earth erbium doping in the class matrix, comparing with another element in the system. The elastic properties studied and the result was shown in the figure 24 and 28, which utilized the longitudinal and shear velocity of zinc silicate classes against the boron and erbium weight percentage. As seen in the figure, the VL and VS show decreased zinc and increasing trend as a doping concentration increase. The decreasing might be related to the gradual forming of non-bridge oxygens atoms, which reducing the class connectivity. Meanwhile, the rise in the class density and rigidity is directly proportional to the increasing the ultrasonic velocities. And the result from elastic models against the boron, we can see there is increasing and decreasing behavior with addition the boron and erbium. The previous study has similar elastic behavior to the present study. The decreasing trend is caused by reducing the number of bonding in the zinc silicate classes system. Increasing that is connected to the rising in the class density, which causes the class structure is become compact and rigid. As we can see in the figure here, with increasing the erbium concentration, the position ratio will decreasing first from 3.2 until 3.3, 0.322, and then increasing after 0.3 weight percentage from erbium. And the highest value is 0.35 with 0.05 erbium. This result explained by the increasing the amount of non-bridge oxygen in the class structures, creating more space and lower network connectivity. There is the surface plasma resonance. I get it in UKM. This result we can see will increasing the shifting with increasing the percentage of the boron. The observed small shifting is the value about 3 to 8 nanometer, with an increasing the boron from 0.1 until 0.3 weight. We believe that the shifting can enhancing the surface plasma resonance signal, which leaded to development of the lower cost and sensitive optical sensor. There is the SPR resulting from the erbium doping zinc borosilicate classes. We can see the small shifting from 3.3 to 5 nanometer, with increasing the erbium concentration from 0.01 until 0.05. In general, used shifting in the minimum reflective mean that the incident angle, the product maximum coupling of photon energy into the surface plasma chains in response of the change in the refractive index at the sensor surface due to the bonding of the analyte. As a conclusion, the main objective of this part of my research to enhancing the absorption and transmission efficiency of surface plasma resonance and surface enhanced Raman spectroscopy class substrate. Therefore, the first objective was achieved, obtaining a very transparent substrate from the samples by repeating the experimental more than 1 times using 2 stages of melting and different concentration of zinc oxide and boron oxide. The result from XRD indicated the amorphous phase of the samples as 0.6 from zinc and all P2O3 and erbium oxide doping zinc borosilicate class. The result from FTIR is a good agreement with the result of XRD spectroscopy, which revealed an amorphous phase for the entire zinc silicate and zinc borosilicate and erbium doping zinc borosilicate. The result from optical band gap showed that the value of the energy band gap decreasing with the increasing of the concentration of erbium. The surface plasma resonance result demonstrate that the concentration of the erbium increasing. There is a minor shifting in the wavelength 3 until 8 nanometer. As a result, biosensor application are possible with this glass substrate. This is my Gantt chart. I tried to complete all my result because I submit my result for the DSC and the AFM. I waiting the result until now. I starting to writing the journal and writing the thesis. This is some of my references. Thank you for listening.
Thank you, Ali Jabbar. And I invite peers to ask questions about his presentation. So, Injan, are you going to chat? Use the chat? Okay, go ahead. Okay, let me read. Yinjian has a suggestion. It was recommended in PL peak analysis to do deconvolution rather than directly extract the position of highest peak intensity. So,
Okay.
Jabbar, you want to comment on that?
Sorry, Doctor, can you repeat the question?
It was recommended in PL peak analysis to do deconvolution rather than directly extract the position of highest peak intensity. This is
I am
suggestion.
not sure about that. Okay, Doctor, I will try to discuss this first with my supervisor, and then after that I will decide it.
Okay. Maybe we need some questions at one moment, so that there are interactions. Raymond Chiang.
Yes. Yes, I have a question. So, may I ask that because you have do for the Raman spectroscopy, so in your opinion, which excitation is better for the Raman spectroscopy?
Okay, thank you, woman. Generally the frequency of light is inversely proportional to the wavelength. When the other parameter being equal, the shorter excitation wavelength will yield a stronger Raman signal That is one of the reason why given a choice, Raman spectroscopy prepare shorter excitation wavelength. Do you get my answer?
All right, thank you.
Welcome.
Okay, we have another question from Jiwelo.
Yeah. Hi, Mr. Ali. I have two questions. Yeah. For the first question, from your research, may I know what is the main application of the surface enhanced Raman spectroscopy? And the second question is like, yeah, for this slide, the refractive index, why your refractive index decrease with the increase of the boron oxide content? Yeah.
Okay, thank you, Zoe. For the first question about the application of surface enhanced Raman spectroscopy, the surface enhanced Raman spectroscopy is the Raman spectroscopy technique used that has been widely used in food safety, environment monitoring, and in medical diagnosis, treatment, and drug monitors because of its high selectivity and sensitivity and assembly and can identify the molecular structures. Excuse me, what is the second question?
Yeah, for second question is like, for your refractive index for the why the refractive index decrease when your boron oxide content increases?
The refractive index of the glass substrate will decreasing with increasing of doping concentration. This decreasing could be explained by the incorporation of the relativity low atomic weight for the boron, maybe about 10.8, and the smaller ionic radius of boron, comparing with another element in the glass matrix such as zinc and silicon. Do you get my answer?
Yeah. So, which one is your optimal concentration for the boron oxide?
The optimal concentration for boron oxide is 0.3 weight percentage for my result.
Okay, thank you for your answer.
Thank you so much. Thank you.
Okay, thank you, Jabbar. So I think we should try to move on to the next presenter, the final
Thank you,
presenter.
Doctor.
Okay, thank you. The final presenter of the day and also of this particular semester, Muhammad Syahmi. Are you there?
Yep, I'm here.
Okay, you can share your slides.
All right.
So he's doing his master's and presenting his final seminar on indoor localization based on Earth magnetic field.
Right, Assalamualaikum and very good afternoon to everyone. So my name is Muhammad Syahmi bin Samsuri. So I'm under supervision of Dr. Muhammad Amiruddin bin Abdul Rahman. So my title project research is indoor localization by using magnetic field. So there are the contents for this presentation. So we go first with the introduction on indoor localization, problem statement, and objective of the research, literature review, methodology, results, conclusion, and the last one is a reference. Alright, so let's go for the introduction first. So localization enables tracking of human activities and localizing places, which helps improving productivity and save time. So localization involves indoor and outdoor. So the technology is work based on a satellite for outdoor. Let's go for the outdoor localization first. So the technology work based on the satellite navigation system such as Global Positioning System, GPS, Global Navigation Satellite System, GLONASS, and Galileo. So satellite of GPS will be transmitted information about the user's location and position, and then the signal will transmit to the GPS receiver, which is user mobile phone or navigation device. So, but then for outdoor localization is give a bad result to the indoor localization. So that's why we cannot use satellite for positioning in indoor location in the building. Right, so for indoor localization, there are various types of technology that have been invented to develop indoor localization. So for example, by using a geomagnetic field, which is Earth magnetic field, and then Wi-Fi based positioning, and another one is a RFID positioning. Uh, so I give I give a scenario. So why indoor location is needed in our daily life. For example, when we go to the library and we want to find a some book, then we ask the librarian to help to show the direction. Then we go to the direction state, but somehow we are lost. So why not indoor location is developed to improve our daily life. Next, I'm using a geomagnetic field or earth magnetic field as a medium for positioning. So magnetic field is a vector field, so its signals pattern have 3D orientation, which is come with x axis, y axis, and also z axis. So I'm using a mobile phone as a medium to measure magnetic field, as nowadays mobile phone come with the magnetometer. So the figure shows that measurement of the magnetic field. So the yellow one is a axis measurement, the blue one is a z-axis measurement, and then the green one is a y-axis measurement. Next is there is a factor. Next is there is a factor that affect the magnetometer. So first is hard iron and also soft iron. So this factor will distort the measurement of the magnetic field. Let's go for the soft ion distortion first. So soft ion distortion is the result of material that distort a magnetic field, but does not necessarily generate a magnetic field itself. And therefore, it is a not additive iron, nickel, and concrete of the building, for example. So it will generate a soft ion distortion. Soft ion should not be eliminated as it is from environment surrounding of the building. So eliminate soft ion effect, just show the true north direction as example. So soft ion distortion is needed as it shows specific signature for every reference point on the map, on the indoor location. Next is hard ion distortion. So this hard ion distortion is produced by material that exhibit a constant additive field to the earth magnetic field. So thereby generating a constant additive value to the output of each of the magnetoaxis. So hard ion effect are constant regardless of rotation or position of the sensing platform. This constant offset can be stored on calculated and subtracted from the raw magnetometer. So usually high ion distortion is caused by the device itself. So for example, I'm using a mobile phone. So high ion is come by the device itself. For example, the speaker of the device and also the temperature of the device. So if the temperature go higher, the higher distortion will give a lot of give a large distortion to the our measurement of magnetic field. Right, so there are advantage of Earth magnetic field. So why using Earth magnetic field as a medium for localization is because of it is stable as it is a natural resource, and it gives more accurate signal as it is a 3D orientation vector. And then it is a low consumption of energy as it doesn't need any technology other than mobile phone and also Earth magnetic field. So next is it is a low cost from other technology that have been invented. For example, if I'm using a Wi-Fi for a medium for position, so I need to have a lot of router. So for localization. So next is problem statement. So the main problem from previous research is lack of static localization. So magnitude of magnetic field is very small as it is in a micro Tesla unit. And magnetic field is depend on hard iron and soft ions. For specific places, they have their own reference signal. So in contains data, which is data that is collected by walking a path, can be a reference point in a database. So it is not possible to implement pattern matching algorithm to a magnetic pattern to determine location. An increase of computational cost might happen when using multiple algorithms. So therefore, data processing is needed to reduce the computational cost. So my objective research is to improve technique and method for measurement geomagnetic field indoor localization. And next is to design and develop path algorithm from the discrete data to continuous data. And next one, and the third one is to predict location pattern based on KN pattern matching algorithm. And the last one is to analyze different similarity distance of KNN algorithm to evaluate the performance of magnetic field localization. So this one is a lecture review for indoor localization. So magnetic field, so based on the magnetic field, why actually because of magnetic field, because it can be predicted by using fingerprint method. And there are a uniqueness of the magnetic field, which is use the distortion of the magnetic field as a map picture to localize user. And then there is a T characteristic has used unique signal pattern, constant over long period of time, and then uh, uh, it is a vector, so involve x, y, and z axis. So some of before research before algorithm is used can-N in magnetic base positioning and also neural networks algorithm. So my methodology is divided by two phase, which is offline phase and online phase. So for offline phase is a phase that collecting the database. So first magnetic signal measurement is collected at reference point location, and then need to filter, which is need to eliminate the high ion effect. And then the magnetic field signal is processed and be the database. The next is online phase. So online phase is a testing phase, which is collecting a signal measurement at unknown location, which is in term of path data or continuous data. And then we need to filter, which is eliminate the high ion, and then put into the path algorithm. Sorry, path algorithm, and then process and analyze in the KNN algorithm for the matching process. So next is I'm using Samsung A52 as a my mobile phone to collecting the measurement. So my device is built in with the magnetometer. So by using the software application, which is Physics Toolbox, and then I need to email to store the database and then analyze by using the MATLAB for the algorithm. So this one is a specification for my device. So the operating system is Android 11. And then the chipset for my device is Snapdragon 720G. And then the feature, the basic features that we need for this kind of research is magnetometer. So it states that there is a compass. So it means that there is a magnetometer. Right, so next is mapping. So I've been done the experiment at a tutorial room at College Mara Kuala Nerang. So there are 35 reference point and one continuous data. So the green one is the reference point. So I need to collect for each reference point and make it as a database. And then continuous data is a data that collected in a one-way path. So next is experiment procedure. So offline phase, signal is collected at every single reference point as a database. Then signal is collected for 4 directions, which are north, south, east, and west. So every direction measurement is collected at 1 minute. So 1 minute we collect 600 data as the frequency used is 10 Hertz. So for online phase, signal is collected in the pathway on reference database. The data is in a continuous data type. So this one is the orientation and the direction of the device. So next is method for eliminate the high ion. So the magnetic field measurement for high ion is taken right before start the experiment. So we need to take the measurement for high ion first, and then we can start the experiment. So how to take the measurement for high ion? So the measurement is taken by rotating the device 360 degree as figure below. And then the data processed in MATLAB to get the offset of x-axis and y-axis. So when we get the offset of x-axis and y-axis, and then we eliminate by subtract the raw data with the offsets. So after the data of high ion is recorded, the experiment can begin. So the data of high ion then extracted and analyzed. So the data then analyzed by using formula to correct the x and y offset. So magnetic field data then subtract with the x and y offset to get the actual value of the measurement. So the formula is in the figure. So first we need to get the x of offset first. So to get the x offset, so we need to find the maximum of value of x vector and the minimum value of x vector, and then divide by 2, and then you get the x offset. And then to get the y offset, we need to find the y-axis maximum measurement of the magnetic field value, and then get the y minimum, and then divide by and then minus, and then divide by 2. So by the raw data, so raw data of x, we subtract with the offset, and then you get the actual value of the x-axis measure magnetic field value, and same goes to the y-axis. Right. So next is a path algorithm. So for offline phase, the collecting data is in discrete data, refer to the reference point. So the objective for a path offline phase path algorithm is need to combine the reference point and form into several path for KNN algorithm. So the flow is as shown in the figure. So first by the raw data, and then we filter to eliminate the ion, and then mapping, which is attach the reference point with the data, and then make it as a database. So combine the reference data to form a several possible path, and then form the database and ready for the KNN algorithm matching. So next is for online phase. So for online phase, the data is in continuous data type. So data is set to split into several paths for KNN. So we need to split the context data into several paths for KNN, and then that's what, because of our offline database is in several paths, so that's why we need to split it. So first, raw data is filtered by eliminate the high ion, and then filter data by every 1 second. So next is find the value of change in x-axis for every 1 second, and then locate the fluctuate data or the highest peak of the data, and then we can split the data into several possible paths. So this one is a methodology for KNN algorithm. So first we need to find the average of magnetic field path signal, and then we need to find the minimum distance. So to find the minimum distance, we can use 3 type of distance, which is first is Euclidean distance, and the second one is a Manhattan distance, and also the last one is Minkowski distance. So Euclidean distance is the shortest distance between 2 points. In a dimensional space, it is used as a common metric to measure the similarity between 2 data points. And then for Manhattan is a distance metric between 2 points in an n-dimensional vector space. And then for the Minkowski distance is used for nearest variable distance to find the similarity of distance between 2 vector or more vector. So as we can see, there is a power of R. So Minkowski is depends on the value of R. So if the value of R is equals to 2, the Minkowski will be the Manhattan distance. But if R value is equals to 1, so it will be in the Euclidean distance. So next is this one is a comparison between the type of the distance. So let's say we have 2 points A and B. So the 2 points, so the Euclidean is the shortest one, and Manhattan is the point between A and B, which is in term of vector. So it so the result will be more detailed than Euclidean distance. So next is the results. So for elimination of ion, I'm so sorry because I have a sore throat. I'm so sorry. So figure show the x-axis measurement for the first week and the second week. So the red one is the first week, and then the blue one is the second week. So the measurement is at same location and same reference point. So it showed that either of these two measurement is shifted because of it should be constant for same because of same reference and same location point. So the mean value for the first week is at 10.5351 microtesla, and for second week is at 3.3058 microtesla. So this measurement need to be filtered to eliminate the hard iron effect. Right, so figure show. So next is figure shows graph of composition of hard iron of measurement on the first week. So because in our method is we are rotating the device by 360 degrees, so the result will be like this. So it will show the green circle. So green circle is a before hard iron composite, and then the red one is a after hard iron composite. So if you want to know there is a hard iron effect, we can see on the green circle. So the green circle is not at the center 0, 0. So it shows that there is a hard iron distortion. So after we eliminate it by using the formula, so we get the red one circle. So which is the red one is at the center of 0, 0. So after eliminate the offset of the hard iron for x and y value, the red graph show the center at 0, 0. So the hard iron effect then eliminated with offset of x and y 24.9200 microtesla and 29.8600 microtesla respectively. So next, the figure show the graph of the composition of hard iron of measurement on the second week. So the hard iron effect is eliminated with the offset of x and y is 18.6300 microtesla and 34.3350 microtesla respectively. So after eliminate the hard iron, so we get the constant graph for both week. So the mean for the first week and second week are negative 14.3848 microtesla and negative 15.3241 microtesla respectively. So it showed that the measurement for both weeks are stable. So and then it's suitable to do the positioning and localization. Next is the path algorithm. So for offline phase, figure show there are 35 reference points in total. So the data is in discrete data type. So the data is set to combine when we enter the data into the algorithm by using the algorithm. So the data are combined to form 28 possible paths. Then the data are set to several possible starting point. For example, point number 1, number 4, number 7, number 29, number 24, and number 16. So there are possible path. So total possible path is a 28 in total. Alright, so next is path algorithm for online phase. So figure show the graph of the contents data. So the objective for path algorithm in online phase is we need to split the data to form a several path. So figure show that the graph is continuous data. So at time equals to 9 seconds, 16 seconds, 24 seconds, and 38 seconds, it show a large fluctuate on x and y axis as it show that the path is turned around. So the path that is turned around, we need to split because before it turn around, so we can let it be a path. So the value of time stated are key value to split the continuous data into 5 paths. So condition of each path is the straight path. So from the value of the time, so the data is split into 5 parts by using the algorithm. So to detect the turnaround data, the matching algorithm is used to locate the fluctuate data from the existing context data by using change in x value formula. So x2 minus with the x1, and then we get the total change in x value. And then threshold is set to 9 microtesla for locate the turnaround data. So the data show time at 9 seconds, 60 seconds, 34 seconds, and 38 seconds, and the data split into 5 parts. So the diagram show the graph for every path. So all the 5 figures show the path data and have signature signal. So it'll be easy to analyze in a CAD and algorithm later. So for other objective is under progress, right? So the conclusion is hard ion should be eliminated because it is from internal device structure effect. So soft ion should not be eliminated as it is from environment surrounding of building. So eliminate soft ion effect just show the true node direction as example. So the soft ion distortion shows specific signature for every reference point. By combining discrete data to form a context data, which is a path data, it will be easier to compare in KN algorithm because it is the same type of data. So offline phase has 28 possible data, and for online phase need to locate the turnaround position first by using time so that the data can be split into the path data. So this one is reference. Thank you.
Okay, thank you, Syahmi. So I invite questions from your peers. Anyone? Zarina? Go ahead.
Assalamualaikum. Thank you, Muhammad Syahmi, for your presentation. Yes, I would like to know for your method collecting for the online data pathway.
Yes.
Okay. How many times that you repeat the procedure to get the online phase? Because on your slide you show that you will collect the data from the point to point, right?
Yes.
Okay. How many times you repeat the process? Either one time or is it need to do on multiple times?
All right. So for offline phase, for online phase, I will be do for one time because of we need to compare with the offline later. So that's why just need to one time because of it is a testing data.
Okay, so once collected for the online data and you will compare to the
Yeah,
offline data. Offline
Yes.
data is the map of the building, right?
Yes.
Okay, so you compare the accuracy of the online with the map of the building.
Yes.
Okay, thank
All
you.
right.
Okay, any other questions? On the tongue? Go ahead.
Okay, Prof. Thank you, Muhammad Syahmi, for a very interesting presentation. Because I see just now your slide show that your threshold you set is 9 micron Tesla, right?
Yes.
May I know what is the reason you set the threshold value is, sorry, a bit noisy here
It's
because
okay. It's okay.
it's an event app. May I know the reason why you set the threshold value is 9 microns Tesla?
All right. So the reason why because I set the threshold for 9 microtesla is because of the peak before the, as we can see here. Okay, as we can see here, the value of peak after the turnaround position. So the highest peak is more than 9. So because I need to set to 9 microtesla. Wait. Okay, so let me explain again. Right, so I set to 9 microtesla because of, as you can see in the figure or the graph, so the 9 microtesla is the peak of from a path to a path. So that's why I set the threshold to 9 microtesla. So as we can see, they fluctuate on, for example, at this point. So this point shows that there is a turnaround because of there is a large fluctuate. So that's why I put 9 microtesla for the threshold. But then, as you can see here, because of the data of magnetic field is not stable, is not constant, as it show the specific signature for the path. So for example, at this point, it has also fluctuate data, but then there is no turn around position because of the fluctuation data is not more than 9 microtesla, so it lower than 9 microtesla. So that's why I use threshold for 9 microtesla. That's all.
Oh, okay, thank you for your answer.
All right.
Okay, I allow another one more question if there is any. I guess not. So, okay, I think we'd like to thank you, Syahmi, for the presentation.
All right. Thank
And
you.
I will stop the recording now, and then I will take up your attendance after this. Okay, I will stop the recording now.